We're going to take a look at the inverses of square matrices. Okay. Honestly, by hand, you're pretty much only going to have to deal with 2 by 2 as far as inverses go. Larger, like the row echelon form, row reduced echelon form, you might have to deal with 3 by 3. But for inverse matrices on the quiz, you're only going to deal with 2 by 2 ones. Okay. We'll look at both, and we will use the calculator a little bit. The idea of the inverse is something that allows you to, and we've talked about this before, allows you to cancel off a matrix. If you multiply a matrix times its inverse, either way, the original first or the inverse first, they end up coming out to just be the identity. The identity times anything does what? Yeah, it leaves it the same. Doesn't do anything to it. So that just leaves you with the inverse of A times B in this case. Okay. This should be familiar from last year. All right. Now, because of that, if you want to verify something is an identity, then, or is an inverse, then the idea is if you multiply it either way, you're going to get the identity. So if I want to test for whether something is or is not inverses of each other, well, do the multiplication. So if I have these two matrices and I want to figure out if they're inverses, I'm literally just going to take A times B as well as B times A. There's a couple of oddball matrices out there that if you multiply them together don't actually give you the identity both ways. They might give it to you one way and not the other. But most of the time, as long as it works one way, you're good. I would still check both real quick because honestly, if I'm going to do A times B, what am I going to get in the top left? Well, give me the state before 1. Yeah, negative 2 plus 3. Do top row, left column. Top right?
Negative 2 plus 2.
Bottom left?
3 plus negative 3.
Yeah, 3 plus negative 3 or 3 minus 3. Bottom right?
3 minus 2.
3 minus 2. So in other words, 1, 0, 0, 1. So that's your identity. So that confirms it that way. When you do it the other way, what's going to be in the top left when you do B times A? Negative 2 plus 3, because here you're doing this row times this column, right? B's got to be first. So negative 2 plus 3, top right? Negative 2 plus 2. No, not negative 2 plus 2. So you're doing this row. 1 plus negative 1, or 1 minus 1. Okay? Remember, we're doing B first, then A. It's easy to do, especially when they're written that way, because your brain wants to do it the other way. Bottom left? 6 minus 6. Bottom right? So bottom row, right column? 3 minus 2. So it works both ways. That means that these two things are inverses of each other. So if they ask you to prove that two matrices are inverses, just show both ways like that. Not too bad? Okay. For this, if I just want to find the inverse, there's a couple different methods for this. Honestly, if it's a 2 by 2, I just kind of use what I consider to be an easier method. Okay? If you want to find the inverse of A, matrix A is equal to the matrix A, B, C, D, just to generalize this, okay? Then the inverse of A is going to be equal to 1 over the determinant of matrix A times a slightly rearranged version of this matrix. So you swap your top left and bottom right and flip the signs on top right and bottom left. How do I find determinant of A? Yeah, AD minus BC. The way I honestly remember that, it'll always follow this pattern. Starting in the upper left, you got a fish swimming downstream. Okay? It's one way to remember it. Whatever way you want to, AD minus BC. So in this case, what's your determinant? Now, when you do this, follow that pattern, you get 3 minus 2. So it's going to be 1. Then your rearranged matrix, what's your top row look like?
3, 2,
2. Now, honestly, if you want, do the diagonal instead. 3 and 1, flip those. What are you going to do the other diagonal? 2 and 1. I'll just flip the signs. You're going to multiply by 1 over 1. In other words, nothing changes. So this would be your inverse. Okay, I like that process. That's the fastest in my opinion. There is another way to do it, but for a 2x2, to me, this isn't worth the effort. But you can actually write it as a really big augmented matrix, where I would take that A, B, C, D, augmented with an identity matrix, and then row reduce it. Get it down to RREF. When you do that, that's going to give you the identity first, and then the second half will be your inverse. Personally, I just go this route. If you want to, that will work. If you use Gaussian elimination and get it down to this, that will work. I like the other way better. That's going to be up to you. Okay? Now for larger matrices, though, that's where you're kind of going to want to use that method. Okay? If I have a 3x3 matrix, I'm going to use that identity method, where I mix it, make that larger matrix. So you get 1, 0, 0, 0, 1, 0, 0, 0, 1. And then find the row reduced echelon of that. Oops. Go ahead and do that. Now, I also said 3x3, if I'm asking you to find the inverse, you're going to be able to use your calculator. So go ahead and do it on the calculator. Unless you really want to do it by hand.
So for it on a calculator, it's going to be all 2x2s?
Well, if it's inverses. Now, you might have the stuff we did yesterday and the day before, you might have that stuff. Like sections 1 and 2. Anything from section 3 is going to be a 2x2 matrix. Yeah. Actually, that one's almost dead.
Thank you.
What are your dimensions going to be on that matrix? 3 by 6. What do you end up getting for a right hand, the right half, 3 by 3?
4, -1, -1, 0, 0, -1, -3, 1, 2.
Everybody get that? And then this would be your inverse. Does anybody know a different way?
Type in the original one and inverse it on the calculator?
Yeah, type in this one. There is actually an inverse button on your calculator as well. But if you had to do a 3 by 3 by hand, you'd pretty much be stuck doing this.
But we don't
But we don't
have
have
to.
Well, unless I decide to throw one on the test for the heck of it.
Please don't.
Well, please don't.
On test? Yeah.
Wait, so
Right now,
do it
it's
again?
you can use the calculator. That could change.
Well, I'm hoping it doesn't change us.
Okay.
Is that like depend on if we do good on the first one or something?
We'll see.
On
Yeah.
there and it's on the right side.
Process.
Oh,
I
hard,
didn't quite understand.
So you put this into your calculator, right?
Yeah.
So you did that.
Yeah.
Then you just do RREF of it.
That's it.
And that gives you this big matrix here.
Yep.
And then this right half of it, that's your inverse.
where's
Or you could. So you put in just the.
You put in this whole thing here.
Okay.
You got to put in this 6 or the 3 by 6 matrix. Okay? Because you got to basically take your original matrix and then take the identity for a 3 by 3 and put it on the right side. Now this will work for a 5 by 5 as
I
well.
remember.
Then you just have the identity on the right, and you'd have a 5 by 10 matrix.
Oh.
So this works for larger matrices. Now, admittedly, there is an inverse button on your calculator. Okay? If you look at the matrix button, don't second it. That's your inverse. You can't actually just input this as matrix A and then do a to the negative 1. On the TI calculators, that will do that for you. But if you don't have a calculator, this is a technique you need to use. And then go through your whole add row 1 to row 2 and get rid of stuff and whatnot.
Have a calculator is your point?
His point is to be the calculator.
My point is AP Calc next year, you don't have a calculator.
That's for next.
Wait, we don't have.
For part of the test, you do not have a calculator in AP Calc, right? And you will need to be able to do this stuff without a calculator. Possibly matrices on that level, yes. So it's good to know that technique. This is just what I talked about earlier. I just jumped to that for the 2x2s rather than deal with the matrix version. So why would it say this though? Why would it say find, if possible, the inverse of each matrix? Yeah, if the determinant's 0, then it doesn't exist because it's 1 over the determinant. So first thing you need to find is what's your determinant. What's your determinant for A here? Yeah, you're going to get 20 minus negative 3, so 23. Here, what's your determinant? 0. You get 4 minus, or 8 minus 8, sorry, you get 0. So this one, your inverse of B, doesn't exist. For A, well, you're going to have 1 over 23 out front. What are you going to have inside the matrix on the prime diagonal? 4 or 5.
1 negative 3.
1 negative 3. Those do not switch places, they just flip signs. And honestly, sometimes the book will leave it this way, sometimes they will simplify it. I would honestly just simplify it. If you're going to do more work with it, I'd probably leave it the way it was. If this was just the answer you're looking for, I would distribute it. Because it's a scalar multiplier out front, so you just end up with that. Make sense? Okay.
So flip top left and right bottom, and then flip the signs on the other two.
Yep. Okay. Yeah, and this just talks about, again, you can take the inverse of a matrix times the constant matrix to give you the solution. And that works no matter the size of the matrix. So you will have word problems in this section again. And wouldn't be surprised if you see 1 or 2 on the quiz as well. You invest 15 grand in AAA rated bonds, AA rated bonds, and B rated bonds, and want an annual return of $1,140. The average yields are 6.57 and 9% respectively. You invest twice as much AAA bonds as in AA bonds. So how many inequalities, or how many equations do you have here? 3. What are they?
Two AAA plus AA plus B equals 15,000.
Yeah, I don't want to write quite that much, so I'm going to just do X, Y, and Z.
Right, I guess that works.
But what did you say again?
It was 2x plus y plus z. Because you invest twice as much in AAA bonds.
But what's that going to equal?
15,000.
If I'm doing double, if I do 2x plus 1y plus z equals 15,000, won't that be more than 15,000? You're on the right track. You'd actually just do 1x. X plus y plus z. That's going to be 15,000. One of my other equations is going to have to deal with this.
Oh, okay.
Would be 2y equals x.
Yeah, so if y is AA bonds, you invest twice as much in AAA as you do in AA. So yeah, x is going to be equal to 2y. And then what's the third equation?
The 6.5.
6.5?
0.065.
0.065x.
And then all of that has to equal 1,140.
Okay. Now with these numbers, what we're going to do is put them into a matrix instead. But one thing I would actually need to do first with this middle equation is what?
Get the same y.
Get in the same forward. Move it over so it's equal to what? 0. So in other words, you get these three equations down here.
Alright.
Okay? How much using an inverse matrix to solve? So what's the matrix you're actually going to plug into your calculator? There's actually two of them here.
111.07. 09.
And
And 1 minus 2 and 0.
1, negative 2, and 0. Now, on your calculator, I would honestly use that inverse button if you have it available to you. So take the inverse of that matrix and then take that times what?
13,040 and 0.
Yep. So I would multiply that out. Go ahead and do it. See what you get. So what do you get?
6,000, 3,000, 6,000.
What are those equal to?
How much money for each bond?
Right, so you'd write that out. Now, equation-wise, this is X, Y, and Z. And then you'd write out what those are. So $6,000 in AAA bonds, $3,000 in AA, and $6,000 in B. Now, what are they referring to when they're talking about bonds, AAA, AA, B? Any ideas?
Isn't it a government thing where you can buy a bond at a set amount of money and then there's an interest rate on it over
Yeah.
years?
There's different kinds. There's municipal bonds, which are at the city level. There's state bonds, and there's federal bonds. But yeah, it's not actually businesses. You're basically giving the government that money to work with until they pay you back. They're usually fairly secure, which is what the AAA rating means. A lot of countries, though, recently have been starting to lose those AAA ratings. Like Greece is bottomed out and things like that. So it's not seen as a wise investment, so they have a hard time getting money because they're at a much lower bond rate. Anyway, questions as far as math goes? And inverses? Okay. The rest of the time is